Okay, so today I want to discuss a few more important aspects of programming. The first thing that I wanted to explore with you is how do we pass parameters through a function interface? I mean, by the question, how do we, in the sense that, how do we decide when to pass when? Because there are so many choices, right? How can you nail it down to exactly how you're going to write down the function signature? Now, last time I used this word function signature, some of you have probably problems with using this term, signature. Please feel free to interrupt me, as I said, in the class when something is really sounding really foreign to you. So by signature, essentially what I was meaning is how exactly you're going to decide on the types and the qualifiers associated with the arguments and the decision about what you are choosing to be part of the interface, and based on which you are declaring something, defining something for the function. So it's a signature of the function, essentially. All right, so I think the best way I can do this is
Give me a
probably
second. Is
go
there,
ahead.
what's the difference between a function declaration and a signature?
Signature is about more about you are choosing, first of all, what actually to pass and how exactly to pass. So after you have made that choice, right, the best way to express that would be to write as a declaration. Because declaration is kind of done in order to communicate to the compiler that this is the function signature you can expect, and the definition is what actually fulfills the resolution of the symbol associated with the function name. So signature, in one sense, is, you can say, the blueprint for the declaration and the definition to come into play. Does that help? This is just a terminology that is generally used in the community. Um,
Would it be possible for you to write out like a function declaration and then just show us which part you consider which?
you
Just so
can
we can.
call, you can, I mean, for all practical purposes, the declaration, you can call it as function signature. I'm
Okay.
just expressing to you that before you write the declaration, right? It's a conceptualization you are forming, right? How exactly you're going to form, and that's essentially is the function signature. And therefore, how do you express whatever you have conceptualized? You're expressing using the function declaration. All right. So let's. I think the best way of doing this is directly I write using VS Code some options, and then you try to learn through that. Okay, so I have this folder. You can see that it's going to be comp15/teaching. Okay, and I do code dot in the sense that open the VS Code in the current folder. All right, so I want to create a new file. Let's call it passing params dot cp. Let's call it dot hpp. Okay, so I start defining class A. So notice here that I have actually installed the tab9 extension, which I had written or at least written in the blog, why you can try installing that particular extension, because it is artificial intelligence driven auto completion, it will really speed up your programming. You can see like it's going to just keep on prompting me. Okay,
I have
void.
a question about tab 9. I installed it and like maybe once out of every 100 times it gives me a recommendation. Is that just like how it works? Is it trying to learn how I write, or is that something wrong?
It should be more frequent. You can see that it's just continuing to recommend actually. Anyways, you'll see as we go through. You see, it's just recognizing when I wrote set value, it understands that, okay, maybe you want to look at this. It tries to even complete before I wrote even a single thing. I haven't even defined the member. It kind of completed the program for me. So it kind of prompted me that maybe you want to define the member variable as m value. It just prompting me. I didn't do anything here. And then see, I just typed int, right? It just completed everything for me. So I'm done with this class. Just 3 clicks and I'm done. So all I have done is that I have just defined get value, set value, and so on and so forth, right? Now I want to see what are the different possible ways I can pass the parameters, okay? The most obvious way, so you see like it's even giving me prompts for writing the comments. So first we want to try out pass by value. Okay. So let's write down a non-member function. It's a func1, and where I want to pass by value. So I can say AA. And here, just for testing it out, I can say, so let's see. Why don't we do this? Let's just define another one. Passing params.cpp. And we just copy paste this guy. And here we'll say hash include passing. You see it's going to prompt me hash include IO stream. And then you can do this using namespace std. This just allows you to not every time write this std : cout and so on and so forth. Because of that, you can just write cout directly. So I want to do this before what is the value? You see, it is just prompting me without my saying anything. And then we can say a dot set value 6 cout after. All right, so we can actually copy paste the same thing. So here we'll just change one thing. We'll make this pass by pointer. And here you have to change this because it is pointer now. And then we can do one more thing, which is pass by reference. can do a few more. We can make this star const. Let's do this. Pass by reference. It's const pointer. This is const reference. All right, so we have written 5 different varieties of functions. And then here, first write down int main return 0. All right. So what do we want to call here? So we want to first define. So let's say we defined an object B of type A, and we can do set value, let's say 3. So we can change these functions. Let's call it 2, 3, 4, 5, and that's about it. So we can call this func1. So it learned, as you can see. All I have to do is just press space and then it completes it, as you can see. And then this is all right. Now, so this is what is happening inside the function, right? So what you would like is now to see the effect. You want to see before calling func1, and you want to write cout after calling 1. I missed this. Right, just a few more to go. Right, you see what I'm trying to do here, right? I just wanted to show you after you do these, sorry, func1 pass in B, and then you just repeat this whole block. Func2 to All right, so 2, 3, then 4, and 5. So do you see this, that it is prompting me for in 2 places already? And you know why, right? Because this is passed by pointer, so it is expecting that I take the address of. It is expecting that I take the address of. And then now it is happy. Okay. And do you see this? This is prompting here already. So I don't have to do much. It's already prompted. You know why it is prompting? Why is this is showing up?
The thing that is pointed to is a const.
Exactly. So as soon as you wrote here const, you just are not allowed to do set val. So this is gone. There's nothing we can do here. You cannot modify period. All right. And then here, same thing. You can see this. It is having a problem with this. So I cannot do anything here. So this is how, when you do the programming in a protective manner, you would be saved from doing something which you did not intend to do. So I could not even write that. Okay, that's the first thing you can see. All right. So what else do we have to say about the pass by value? When do we pass by value?
Sorry, I just had a question about something a little bit earlier about the constant, if you're passing a constant pointer or just a constant variable. If it was a dot get value, would that work fine, or would the
Yeah.
function you're calling it on have to be a constant function?
No,
When it's,
you can do a get value here, perfectly fine.
and that's fine, even if the function as you've written it isn't a constant function.
No, if it is not a constant, you mean?
I mean, like, let's say the function get value was written as just like it returns the class A, but it doesn't have sort of a const at the end. That's still allowed, is that right?
If you have written like this.
Yeah, if get value doesn't have the const at the end, you can still do that. Is that right?
So you tell me, what is the effect of, so let's say you have this, you're talking about this, right? So what is the impact of this guy?
It means that you can't change anything within the function. Is
So
that
you
right?
cannot change it here. You cannot write m value equal to here.
Yes.
That's what you achieved by putting a const there. Okay. Now coming back here, if you write down here const, right?
Yeah.
Then that would actually protect you from actually doing a set value. Like you cannot do a set value here.
Okay, but my question was more.
No, not this. Sorry, not a. You cannot do this because you cannot change the value with respect to, if it is a member function. I'm sorry. if this was a member function, this otherwise this const doesn't have any meaning, right? We just discussed.
Yeah. I understand. So if it's a member function, then okay, I think I understand it now.
Because this const applies to the this pointer. There is no this pointer here. It's a non-member function.
Okay.
Okay. All right. So I just wanted to kind of show you more experientially, when you write this down, how just by putting this const was saving you from modifying something that you didn't want to modify. Now let's come back to analysis here. So pass by value. What's the impact of this pass by value here? What happens when this is passed by value?
A is copied.
How is A copied?
Its value is copied in the scope of the function, right?
So it is invoking a
So
copy constructor.
yeah,
Also.
so if you modify it within the function, A doesn't change.
Yeah, so this has the impact of doing essentially A equal to B when you're calling this. And this is essentially invoking a copy constructor. Is that clear? So what does this mean? That means that this is costly, number one, because copying element by element, member by member is costly. But what is the benefit of this by being able to copy?
You will not modify the original.
Exactly. So this is safe because you're not modifying the original value that is passed in. So you're not modifying actually B. So B does not get changed. So we can write here, B should not change upon the above. Okay.
Wait, so costly because of, so more of like a runtime kind of thing, like it takes longer to copy everything, or
Yeah, suppose you have, suppose here, instead of just having M value, you have 1 million, right? And you have written a copy constructor that actually has the effect of copying element by element. It's going to take a long time.
wait, so the alternative would be what then? So that it's not costly. Could you clarify that?
That's where we are coming in. So what do we do in order to move away from it? So you can do pass by pointer, right? So what is the impact of that? So impact of this is effectively A star A, that is the interface here, right? Equal to ampersand B. So what it did here is just made a copy of what? Of the address. So it's just a copy of 4 byte or 8 byte only, right? So there is no copy constructor involved here. It is just copying of the pointer value or the address value, right? So therefore, this has the benefit of, so this is, first of all, cheap. Second, now it is cheap, but there is a problem. What is the problem?
It changes the value of whatever you originally had.
So this is unsafe because this is going to modify, or it is allowing it to modify. Okay, so let's come back to this now, reference. So what is the impact of this func3? So this is essentially equivalent to writing A ampersand A, because that's at the interface, equal to B, correct? Remember, like when it's a reference, it has to be immediately pointing, it has to immediately point out what is it is an alias of. So now at this point onwards, A is an alias of B. So in other words, that value can be referred to as either A or B. So here, when you do A dot set value, so what is changing? Essentially, A and B are essentially the same. So therefore, the value will be changed. So here, what can we write? So this is also cheap, right? Because you have defined an alias. There is no copy here. There is no copy constructor involved. So therefore, it is cheap. It's practically as cheap as the pointer. There is no difference here. And what is the problem here?
also unsafe.
Also unsafe, right? Okay. Now here is the deal now. Now both have similar benefit. So then how are you going to decide when to use pointer and when to use reference? Okay, let's just first complete this while you're thinking about this. So when it's passed by pointer or const pointer, one thing that we improved here is that in addition to this being cheap, this now we have, by using const, we have made it safe. And likewise, this also is cheap and safe. But we have to still disambiguate between this question, when am I going to use this reference and when am I going to use this pointer? Everything else is pretty clear at this point. Any suggestion?
Could you repeat the question, please?
Okay, so we established that these two interface, passing by pointer and passing by reference, they both seem to have the same set of benefit, cheap and unsafe in the case when no constant is present, no const qualifier is present. And when you add the const qualifier, they have exactly the same kind of profile, cheap and safe or cheap and unsafe. So then how would you decide when to use pass by pointer and when to use pass by reference?
You pass by reference when you don't want to change what you're pointing to.
Well, you don't want to change what you point to. You are changing, right? Because we just discussed it. This is just an alias, right? So this is equally unsafe.
Right.
There's absolutely no difference in terms of what you achieved by passing by pointer or passing by reference as far as what we saw so far.
Is it when like perhaps the pointer may have more, let's say, member like variables or functions that you could dereference, whereas pass by reference would only be referring to one like variable?
No, because you saw, right? Like what is the, we described that last week, right? Effectively, one is just saying that, okay, I point to this box. Another is just saying that I'm another name for this box. But once you are in the box or once you're pointing to the box, you have access to everything pertaining to the box.
Passing by pointer has the benefit that you have the star in the signature, so you know what you're passing in for sure, versus passing by reference, which just has the name of whatever when you actually call the function.
Yeah, what
So
you're saying is that at the call site, you can distinguish, maybe this is, I can easily see from just by looking at the call site that this must be a pointer, but here I cannot make out whether it's value or reference by looking at the call site. That's what you're saying, correct?
yeah, so there would be the benefit of using pointers with that versus like a reference, which I personally have only seen in terms of like a const reference versus pointers that are constant or non-constant.
Yeah, I mean, overall const versus non-const, it has pretty much the same kind of effect, both for pointer and the reference. But your additional point is that you can probably recognize just from the call site. So it enhances the readability in some way. That's what you're saying.
Yeah, it enhances the usability for developers that aren't yourself as to what's going on in all of the code.
Yeah, I mean, these days with so much of sophistication, you can see if I just hover over the function, it shows me the signature. I just hovered over the function here. It immediately shows me the signature along with the comments that is above it. I mean, these days the IDs are so good that that I can easily find out what this is. You can see this, and I have not yet compiled also. So in other words, what I'm saying is that that is a good point, but it is not the core point. Any other thoughts? Yeah, today I just want to first of all make sure that you understand when you are defining a function signature, you're absolutely sure when you're choosing your function interface, when you're going to choose what. Can you think of something that pointer can be that reference cannot be?
Null.
Very good. So key point is that this is the third point, that pointer can be null. And references are guaranteed to be not null because it cannot be null. So this is the C++11 way of writing the null pointer. I don't want to go into C++11, but there is a modern C++ style of doing things. And the same thing is true here. So here const pointer, that can be null pointer, and this guaranteed to be none cannot be null pointer. So pretty much now you have got your entire analysis here, how you're going to decide when you are thinking about a function signature. Any question? Since we wrote this program, we might as well just compile it. So Command Shift B for compiling, okay? And then if I have to run it, I just come here and then press enter. Here it gives me the console. If I lose this terminal somehow, this integrated terminal, I can get it back by just pressing Control and so Control key, which is this guy. The Control key and yeah, this thing together. So when you do that, it opens up the terminal. In case I had closed this by mistake, I can bring it back. Okay, so now what this generated for me. So ls minus LTR is just a way for you to see the latest one in the end. So it produced this executable called passing params, right? So all I have to do is /passing params, and this executed the whole thing. So as you can see, what is our expectation when the value should not change? So the first one is supposed to be safe, right? The value should not have changed. And you can see that okay, I spelled it incorrectly, that's why. So values stayed the same after calling func1. You can see that 3. But for the rest of the things, after func3, you can see the value modified to 6, func2 value modified to 6. And of course, for the const one, we could not do anything. So that essentially, we established everything that what we wanted to establish for passing pointers and references. So I hope now you should have a very clear idea when to use what. Now we come back to, come on.
Wait, also you're gonna post the example code, right? Later.
Say that again?
Or could you? Could you post the class
Yeah,
code?
of course, no problem. I'll share everything that we are going through in the class, okay? No problem. Just want to get this out of the way.
Professor,
Go ahead.
I understand the difference between references and pointers, but you were saying we should have an understanding of when to call each. I'm still a little bit confused as to when to call one versus the other than like I get that pointers, you know whether or not it has a null, like you know that it can have a null, whereas references it won't. But like when should you call each, I guess?
Okay, if you want me to summarize this, right? I'll put in this tabular form for you. Okay, just what we just expressed. Okay, just so that you can look at this. Let's write down a table here. And you tell me like after this, whether you still have a question, okay? So you have these four possibilities: void A, B, B, void A, B star B, void A const B star B, void A, B const B ampersand B. These are the 5 things we wrote down. So ask yourself this question: do I want speed? Speed, or you can say that where copy constructor not invoked. Okay. Is it safe? And can it be null pointer? Okay. So this one is slow. This one is safe. This cannot be null pointer. This one is fast because it's passed by pointer. This one is, you tell me, if it's a pass by pointer,
Not safe.
not safe. Can it be null pointer? Yes. When I'm doing const B star B, this is still fast. Can it be safe? Yes, right? Because it's a const, right? So this is still safe. Can it be a null pointer? Yes. Pass by reference? Fast. Is it safe? It's not safe. Can it be a null pointer? It cannot be a null pointer. When you're adding the const here, it's still fast because it's passed by reference. Is it safe now? Yes. Can it be a null pointer? No, it cannot be a null pointer.
But like that is clear, but like by that logic, wouldn't we always want to use pass by reference const?
Well, if you need to pass something which can be null, you cannot use reference.
Okay, I see.
And you will see in this data structure course later on, there will be many things which can be null pointer. Okay, so this I'm just giving you the framework so that you can at least ask this question, that can it be a null pointer, period. If it can be a null pointer, then use a pointer.